compressible flow, speed of sound, and Mach number. Another factor that could lead to compressible flow is the velocity of fluid. The higher the velocity, the higher the probability of a gas to change its density. If the gas is moving faster and faster, it is difficult to us to use meter per second to describe its speed. Because of this, in 1929, an Austrian physicist and philosopher named Ernst Mach proposed to use a speed of sound as a speed reference. Instead of meter per second, we may say that the gas moves at 0.7 times of the sound speed or double the sound speed. It means that Ernst Mach here will use speed of sound as the speed reference. Mach suggests that when the velocity of an object moves at the same speed as the velocity of sound, the velocity will be expressed as m1 or Mach 1. It will read as Mach 1 after his name. So this is a few examples of human-built machine that could move more than Mach number 1. There might be one of the fastest man-made machine is a rocket. It could travel around 20 times of the speed of sound. So this is North American X-15. This aircraft had the current world record for the fastest manned aircraft. Its maximum speed was Mach 6.7. It is about 7,200 km per hour, which is attained on the 3rd of October 1967, and thanks to its pilot, William J. Pitt Knight. So this is Concord, a British-French turbojet-powered supersonic passenger airline that was operated until 2003. It had a maximum speed over twice the speed of sound. It is around Mach 2.04. So it can fly around 2,180 km per hour. It first flown in 1969. Concord entered service in 1976 and continued flying for the next 27 years. It is one of only two supersonic transport to have been operated commercially. The other is the Soviet-built Tupolev Tu-144, which operated in the late 1970s. And this might be the fastest man-built machine on Earth's surface. It's called Bloodhound. So it could reach 1,229 km per hour, and it's around just above Mach number 1. And this is Bugatti Veyron Super Sport. It's known as the fastest car in the world. It can reach a speed of 429.7 km per hour, and it could go from 0 to 100 km per hour in just 2.4 seconds. And this might be the most fastest autobike in Malaysia. Okay, so what is Mach number? Mach number is symbol by m, and the definition is the gas velocity or the velocity of object ratio to the speed of sound. It can be right like this. We could say that gas velocity over speed of sound, or the symbol is V over C. And C here is the third of KRT, which K is the specific ratio, and R is the gas constant, and T is the temperature in Kelvin. If we get M less than 1, we call it subsonic. If M is equal to 1, we call it transonic. If M is more than 1 but less than 5, we call it as supersonic. And if it is more than 5, we call it as hypersonic. So what is the Speed of sound at sea level. Let's say our temperature now is around 30 degrees Celsius, so it's become 303 Kelvins. So we could calculate the speed of sound C by using this equation, and we substitute the value of specific ratio of air 1.4 and gas constant is 287 and temperature is 303. So we get around 348.9 meter per second. So it means that if your car moves at 348.9 meter per second or around 1,256 kilometer per hour, means that your car moves with Mach 1. So bear in mind that speed of sound is not a fixed value. It depends on the type of gas of it pass. So in vacuum, the sound cannot be transmitted because no molecule will disperse the sound wave. For the higher speed, we can use speed of light. The speed of light equal to 299,792,458 meters per second or approximately 108 billion kilometer per hour. So the famous example is the sunlight reaches the earth in 8 minutes and 17 seconds. I hope by having this statement you can imagine the distance between earth and sun. Okay, for example, we have a simple calculation. So calculate the speed of sound at 288 Kelvin in hydrogen, helium, and nitrogen. So what you should do is you need to remember the equation for speed of sound. It is insert kRT here, and you must know that we are dealing with hydrogen, helium, and nitrogen here. So this is not an air, so means that we need to calculate our own K here. We need to calculate a new gas constant. So for molecular mass here, I hope you still remember your chemistry lesson might be 10 years ago. So the hydrogen is around 2, helium is 4, and nitrogen is 28. And the value of K is always given in your exam paper. You could remember for hydrogen is just only 1.4, helium is 1.66, and nitrogen is just 1.4. So if you need a specific, it is advantage for you to know these numbers. So if we substitute the value of K here for hydrogen and the value of molecular mass here for hydrogen, we could get that speed of sound in hydrogen is 1292.7 meter per second. So in helium, so the molecular mass is increased and means that the speed of sound is lesser and become 998.6 meter per second. And the nitrogen is 28, the K is 1.4, and then you get the speed of sound is around 346 meter per second. What you need to understand from the above question is, for example, we have one tube like this, and we put a certain gas inside this tube, and then we put a source of sound here. We hope that this sound will move inside this tube. So in this tube, there is only one type of gas. So let's say this is the inlet and this is the outlet. So when the sound from the inlet hit the inlet area here, so the sound wave will travel, and according to our previous calculation, if the if the gas here is the hydrogen, so sound could travel from inlet to outlet here with speed of 1292.7 meter per second. So if we change hydrogen in this tube with nitrogen here, so we found that the sound wave travel from inlet to outlet here is slower compared to the nitrogen. So the sound of speed travel in nitrogen here is 346.1 meter per second. So the theory is, in low molecular weight gases such as hydrogen, sound propagates faster as compared to heavier gases such as nitrogen. So might be the explanation why the heavier molecule leads to have lower or slower speed of sound. So let's say we have this is molecule of gas A and this is the molecule of gas B. So if your molecule here has lower molecular mass, so means that we imagine that the size is small here, so mean the wave needs low energy to vibrate this molecule and to transfer the wave. However, if we have higher molecular weight here, so we imagine that the molecule is bigger compared to the molecule gas of B here, so it took more energy to vibrate this one and transfer the wave. So means that the resistance of sound to travel from one point to another point is higher in high molecular mass gas. That's why speed of sound travel faster in low molecular mass gas.